Hello, everyone. So this is the assignment on inverse functions. What you might want to do is take a look at the notes, which is right here, inverse notes. Just take a look at them before you begin this assignment. It does a nice job of laying out the idea of the three main parts, although there's parts with doing the graph and with tables that I didn't really explicitly show on this, but it's easy enough to figure out. But you might want to take a look at these notes before you start the assignment. It lays out the idea or the concept of inverse functions. What is the concept of inverse functions? So you take any function, that's the red, and you reflect it across the line y equals x, that's the blue. And why I had it dashed in some of the examples, I don't know, but there's no significance to that. And you reflect it across the blue line, and you end up with the green graph, which is the inverse. The main idea, as far as the features on the graph, is everything gets inverted. So the domain goes to the range with a switch of variable there, in both. The x-intercept becomes the y-intercept, again with an inversion of the x and y. Vertical asymptotes become horizontal asymptotes, so on and so forth. That's actually the simplest concept of everything. And then you'll have to, go to the last page here now, actually find the inverses. So what is that about? For the most part, you'll have to do linear functions. You switch that y and the x around, and then you solve for y. So the number one here is a great example. I want to do an example of all of the functions that we've covered. And so some of these get a little bit crazy in showing some of the work 5, especially with the rational function, but I wanted to show one of everything. So indeed, I did that. And then the third main thing is the composition to prove that they are inverse functions. And we have a healthy number of these problems today also. So you have what you think are the original and the inverse, and then you compose them. What does composed functions mean? It means that you're substituting one function entirely, so the inverse function here, entirely in for x and the other one. So here, the 2x minus 3 would go in for x in the inverse function. And then you should get x when you crunch that out, when you simplify that for both. So that's the three main things that we're going to be covering today. It is, for the most part, a pretty simple assignment and section on your quiz. So problem 1 in the notes, f of x has this domain. What is the range? So basically, all you're doing is you are switching the variable x, literally goes to the variable y. Domain of the original function becomes the range of the inverse. Inverse has a range. Find the domain of f of x with this range. So again, all you do is switch the variable, literally that simple. F of x has an x-intercept of 5, 0. Find the y-intercept on the inverse. Again, switch it around. Make sure you switch it. So this can be so easy that some people just write the same thing again. You have to invert the coordinates. All coordinates get inverted. You'll see that on the next page. So x-intercept on this one becomes negative 3, 0. You have a horizontal asymptote that will go to a vertical asymptote of 4. And then a vertical asymptote of negative 2 will go to a horizontal one of negative 2. And there is example in the rational function example I have, you'll see how from a picture perspective that happens. Actually, I'm not going to show that, but that does happen. Okay, as far as tables go on 7 and 8 here, what happens is you have an entire switch of the x and y. Just make sure, and this is going to happen on your assignment, it does not happen on the notes, that your y's are in order. So for some reason your most negative y was out to the right here, you're going to have to start that at the beginning of your x list here. Just go in order. But it already is in order. So literally it is just an inversion of all the coordinates. Yes, it is that simple. And then the x's become the y's and they just attach to the particular y. So again, on your assignment, you're going to have to start here. This will be the most negative one. That's going to have to go right there first in that x list. Same thing here. It looks like all the y's are in order, so we're good to go. Which, by the way, you should now, in your knowledge of functions, know that up here we were looking at a linear function because we're adding to the original. So this is just a reflection of a linear function about the line y equals x to get another linear function. Here, we're looking at an exponential. We're multiplying by 2, left to right, over and over in the y. And so, although you might not know this, the reflection about the line y equals x of an exponential is a logarithmic function. And so these are all powers of 2. And remember, it's the exponent that you're graphing when you're doing logarithmic data, so on and so forth. I'm not going to go the whole way there, but that exponent comes down, and it's log base 2 of 2 each time. So that's what that is. So graphing an inverse, very simple. All you got to do is get a couple points. So the point 2, 0 goes to 0, 2. And find another one here. So 6, 2 is going to go to 2, 6. And then draw the nature of the graph. That's all you have to do. There it is. Pretty simple work. Okay, here, so we have the point 0, 2. That's going to go to 2, 0. Any point on the line is going to stay there. And then you're ready to, if it's a line, 2 points is enough. Typically, 2 or 3 points is enough to do your work. Okay, so there's the inverse. Pretty simple work. And if there's any where you'll struggle a little bit, might be on these last 4. So this is where it gets to be a little bit of work as far as the algebra goes. So you have to think of this as y equals 3x plus 2. So we're going to switch around the x and the y, and we're going to solve for y. That's how you find the inverse on any particular function. So how's that done? You subtract 2 over, and then you divide by 3. So x minus 2 over 3. That is the inverse function. That's how you find algebraically any inverse function. Now we have to prove they are. What's that all about? That's all about function composition. So f of f inverse. So this means that f inverse, the entire function, which is this, is going to go in for x in the original. And the best way to do that is to just indicate substitution with the set of parentheses. And then notice that the 3 and the 2 stay the same, and then the inverse became the x. And then we're going to crunch that out, which, let me jump down to this one, and then we'll come back and crunch that out. F inverse of f of x. So in this function, the inverse function, f of x is going to go in for x. So what is that going to look like? Get my answer key here to make sure we're good. So that's just going to be 3x plus 2 minus 2 over 3. That's what that substitution is going to look like. And this will take a little practice to get used to. But for the most part, you're going to have to know proving linear functions this way. and maybe one with the square on the quiz, but for the most part, this is the work that you'll need to know. And now what has to happen is that you have to get X in both cases. That's the second thing that you must get. If you don't get X, it's over. You've done work wrong. You haven't proven the inverse. Maybe you calculated the inverse wrong. You must get X. And sometimes the work is really simple. For the most part, it is on this. So the 2 and the -2, drop the parentheses. The 2 minus 2 is nothing. 0, 3x over 3 is x. For the most part, the work is simple. It can get out of control. You see in my notes where with the rational function, because of the nature of the fractions, that it got somewhat out of control there. All right, another inverse function. So this is y here. We're going to interchange. And then we want to solve for y in doing this. So x plus 1 over 2. That's the inverse. Linear functions pretty much all work the same. It's kind of like the same work over and over and over. Okay, so f of f inverse. So we're going to have 2, and then in for x is going to go the inverse function, and then minus 1. And so that becomes x plus 1 minus 1 because the 2's drop out. F inverse of f of x. So now f of x goes into the inverse function. So the -1 plus 1 drops out. And you arrive at x again. Pretty easy work with inverse functions. Nothing too crazy going on. The last two, I did throw other functions in here, which you need to be a little bit familiar with. So this is an exponential, and immediately, what's the inverse? That's a logarithm. We dealt with that in the last unit. That won't go away very easily. So you're going to interchange the variables, and now we want to get at y. So y is in the exponent position. That's going to involve a log on each side, log base 3. So log base 3 of x equals y times log base 3 of 3, which we know is 1. So log base 3 of x is the inverse of y equals 3 to the x. That's something to not forget. So f of f inverse, this is f inverse, by the way. F of f inverse. So log base 3 of x is going to go in for x in the exponent position. Well, this should look familiar. Okay, this was one of our steps when actually we were solving logarithms. And then the 3 to the log base 3, those are going to drop out. That x is going to come down in front. Whatever that is in the parentheses is the answer to the problem. You should remember that from doing our solving logarithm problems. F inverse of f of x. So into the inverse function is going to go through the x. So this outer one here, that's what you start with. And then in for x goes the other function. And that's what can be a little bit crazy at times to think of, all right, what one am I substituting into? It is that outer one. So here's another, this x drops down, log base 3 of 3 is 1. Okay, and then last one, this is a quadratic. Now we have to say x squared is greater than or equal to 0 because we need to take the right-hand side of quadratics or just the left-hand side of them. Because if we took the full quadratic, it would not have an inverse because it would not, its reflection is not a function. So we have to just take half of a quadratic. And now we want to solve for y. And so that involves the square root on both sides. And then we just need to say this because all x's and y's literally switch. That's the inverse. You can put it in front or in back. That is the inverse function. Now, prove that they are. So this gets substituted into x. And now we need to crunch this out. So squaring a square root just means remove the square root piece. That easy. So x plus 4 minus 4. Now f inverse. So f inverse is the main function. And then n for x is going to go x squared minus 4. But there's a plus 4. So this originally was x here. And for x goes the x squared minus 4. And now, so the negative 4 plus 4 drops out. Square root of x squared is x. Okay, completing the note packet for this. So you have 14 problems to do. Pretty easy assignment for the most part on the nature of inverse functions. But take a look at this packet. Does a pretty good job of showing you the concept. Again, there's no significance between the dashed line and the solid. That's just the inverse line with which you reflect the function over.